Bismillahirrahmanirrahim. Assalamu alaikum everyone. In this video tutorial, we are trying to learn Emulator 8086 software, which is very good software to understand 8086 microprocessor. Right? This is an basically an emulator which provides various internal register access where user can actually observe various registers, their content. We can modify their content and understand how different instruction works in 8086 microprocessor. So let's explore this 8086 microprocessor. This is the icon which we have to click, and I'm clicking on it, right? So this is the window you will see when you will click on it. So you can use various uh, options available for user, and he or she can choose easily, but I'm gonna use a new example, right? I can check the code examples, I can check the quick start Twitter or recent files, but I'm gonna use a new file just to show you how one can actually write a code and how one can actually use this interface to compile and execute different 8086 instructions, right? So let's click on new. Again, there are various options available in which you can find and compile your code. I will just choose an empty workspace. I'm not going to use any simple or any template of which is given by 8086 manufacturers, right? So I'm going to use empty workspace. Okay, this is the window that you will see. And before we proceed, we need to understand some of the facts about 86 registers, which we are already following in our theory classes. So we're gonna see those things. So to understand this emulator, I'm gonna write very basic instruction, which is move ax comma 1234 hex, right? So this is the very basic instruction, and I'm gonna try it. What this instruction do, we will see later on, but I want to right now explain how emulator 8086 works. So let's click on button emulate, right? There are various button: calculator, converter, options, save, open, new. So what I'm doing, I'm clicking on emulate button. Okay, this is the thing that which about which I wanted to talk about, right? So let's follow. Okay, these as long as we press the button emulate, right, we will see these three windows. This was original editor which we have earlier, right? And these two windows are the new windows, right? So this window that I'm currently moving is basically the binary file of emulator, and this window is basically source code. Whatever the code I'm going to write, if I'm going to write any further instruction, it will appear automatically in this source code, just to display the user what he or she has written in original source code. So this is just a copy of original source code, and it will be written in the same language in which we have written the code. So you can see this is just a source code given in Assembly, right? So this is a source code in which user can actually check the original copy of the code, right? But this window, which is called binary window, right? This is very important, and we have to understand it very thoroughly, right? Because there are so many things or so many aspects in which you can in this window you can actually access that information, right? So let's discuss this window, right? One can easily see that these are the uh, this area, right? Let me highlight it for you. This area is what, this is what data register we have already discussed in theory classes. These four register AX, BX, CX, and DX are known as what, data registers, in which user will be putting various values whenever he wants, right? Like in this example, I'm trying to put the value 1234 hex in AX register, right? So this register will be used in this specific program, right? Furthermore, a very important aspect of these data register, which is important to note, is these data registers are basically 16-bit registers. Like as we know that 86 microprocessor is already 16-bit microprocessor, right? But these data registers AX, BX, CX, DX, if I name them, these are accumulator, base, counter, and data registers, right? These are specific names of these registers, right? They can actually also split it into 8-bit of information, right? As you can see that this L shows lower byte and this H shows higher byte. So these four registers can be used as 8-bit registers, and if you use them 8-bit register, so these are basically how many registers they will become 8 registers, right? Like AX, lower portion will be known as AL, higher portion will be known as AH, right? Similarly for BX, the lower portion will be known as BL and the higher portion known as BH, right? Similarly CL, CH, DL, DH. So there are 8 register if we consider them 8-bit registers, and if we consider them 16-bit registers, so these are 4 registers, and these registers are very important, and we're gonna see them almost every tutorial of 8086, right? Okay, then we proceed to see the next important section, which is basically code segment and IP. This is very, very important. These two registers are important registers because they actually generate physical address of memory, right? We have already discussed the topic of physical address generation in theory classes. So we know that memory which is attached to 8086 is around the physical address of each location is around 20-bit, but 86 microprocessor is a 16-bit microprocessor, and we cannot access 20-bit location using a 16-bit processor. So there are two 16-bit registers which are involved to generate physical address, and those two registers are segment register and uh, offset register. For code segment, we know that there are various segments in memory: a code segment, data segment, extra segment, stake segment. I have already discussed these segments in very much detail in theory classes, right? So I hope you have, if you are following my theory lectures, so you can easily understand what are the various segments. But right now I'm talking about only code segment, which is dedicated for only code, right? This is the code I'm writing, move AX comma 1234, and this code is going to save inside the code segment, because code segment is dedicated only for program or only for instructions, right? And you know that every segment has to be has to be used two different pointers. One is known as segment based address, which is the segment register, and other register is what, offset address. And for code segment, that is IP. So these two register, code segment will provide the segment based address, right? Let me write it for you so that this thing will become more easy. Segment, let me write here, segment base address, right? Segment base address colon offset. And for code segment, segment base address is CS register or code segment register, and the offset part is what, IP register. So both of these two register actually constitute 20-bit register, and we will see how these 20-bit register is going to be generated in this tutorial, right? So if you remember the formula, CS times 10 10 plus offset, right? The formula is basically segment base address multiplied by 10 plus offset. So I'm using segment base address, the value of CS, right? And then plus multiply by 10 and then plus offset. Offset is what, IP. So this is the basic formula, and I'm trying to generate. So if you see the value of CS is what, 0100. I hope you can easily visualize over here. This is the value, right? This is the value. CS value is what, 0100, and IP value is what, 4 times zeros, right? So I'm going to use the same value over here. So CS value is 0100 times 10. These are values are in hexadecimal, right? Plus 4 times zeros. So if you multiply them, they will become 01 3 times zeros plus 4 times zeros. And if you add them up, it will become equal to 0100, right? So how many bits are these now? These are 5 hexadecimal symbols. So these are 20-bit, right? So this is a 20-bit address, and if you closely observing this address, this is the same address at which we can see the memory is in which the memory location is this instruction is going to place, right? And how we can also check this in this binary window. Let me show you. Look, move AX comma 1234 is an assembly instruction, and we know that when it is going to be written inside code segment, it will be written in terms of binary or hexadecimal, right? Or machine code, right? So if you convert them, they will become some machine code, and it will be written on this address 014 times zeros, right? And where we can actually see this address, look, as I have in the source code file. Okay, let me correct it. This is a source code file, right? And I have highlighted it, right? Look, this line is highlighted, and if you highlight this line in binary window, you will see these green three lines, right? These three lines are green, which means this is the source code, and the equivalent binary code is these three lines. And among these three lines, eventually this first column indicates what? Indicates the physical address, right? And if you see, this is the same address which we have generated over here in 0100, sorry, 01 triple zero, and this is the same address 0100. Furthermore, these are three different locations which are highlighted because this assembly language is around 3 byte. Every location consume 1 byte. So move x comma 1234, it consumes how many byte? 3 byte. So b8 is equal if you convert it into assembly, it becomes b8 34 and 1 2, right? So b8 is 1 byte, 3 4 is another byte, and 1 2 is another byte. How I am converting it, we're gonna see in coming lectures, because there is a special topic we will gonna cover in which we see how one can actually convert assembly language into a binary language. But this b8 is a first byte, this 3 4 is a second byte, and this 1 2 is a third byte. So this assembly instruction will be converted into binary, and it will be equivalent to 3 byte. So these 3 byte will be saved or stored on a three different locations. So first address which will be used 0100, because with the help of CS and IP, this is the address. So 0100, it will store B8. The next address it will be 01001, it will store 34, and 01002, it will store 12, right? Just to verify it, right? I can actually use another instruction. Let me use it for you. Let's say I change this code and I write move bx comma 5678, right? This is another instruction I'm adding into my code, and I will again press emulate button. So now I will see two different instructions. Okay, let's emulate. Okay, if I am highlighting this instruction now, this first instruction, these 3 bytes are highlighted, and if I highlight this instruction, so you can see that next 3 bytes are referring towards the equivalent byte information of next instruction, right? So you can see that this is how memory is storing your instruction, right? And how you can actually calculate that physical address using with the help of CS and IP, because we are actually right now talking about code segment, right? Or code portion of memory, right? Furthermore, one if you highlight any instruction, right? Furthermore, right? Okay, one thing I wanted to discuss. Okay, let's discuss it first. If we again uh, so this address, right? This is the physical address, right? There is no doubt about it now. This is a physical address. And if you talk about the logical address, how one can write logical address? Logical address will be written as CS colon IP. I have already told you. So CS value is what? 0100 ratio, and then 4 times zeros, right? So every physical address will have a logical address, which can be actually written like this: 0100 colon 4 times zeros, right? And if you click on every single location, you can actually see this logical address in this column. If you see, this is the location where we are actually observing logical address. Look, this is the what? This is the logical address portion, right? If I highlight this specific location, its address is shown. If I highlight this uh, location, this address is shown 0100 colon 3001. If I highlight the next instruction, this is the physical address 01002, and the logical address is what 0100 colon 0002. So in this way, this binary window of emulator will let you know where this specific instruction is stored in memory, and what is that, what is the physical address and what is the logical address. I hope you have understand this part of this tutorial. Right now, let's proceed to further various segments of this emulator 8086. Right, then we come to another important area, which is called stake segment and base pointer, and source index and destination index. Right, these, okay, let me, stake pointer, base pointer, source index, and destination index. These four registers are used as what, offset areas for various other segments. You know that there are four different kinds of segments in memory. We have discussed already in this tutorial code segment. Another segment, if I mention it, another segment which is available is a stake segment, right? Other segment which is available, data segment. Another segment is extra segment. So there are various various segments available, right? Code segment we have already discussed. Okay, for every segment we have a segment base address, right? Segment base address and offset part, right? So for segment base address we use segment register. As for code segment we were using what, CS. So for if you notice it, there is SS for stake segment, there is DS for data segment, and there is ES for extra segment. So these three registers, segment registers, right? Stake segment, data segment, and extra segment, these three registers are actually showing the base address or the segment base address of their corresponding segments, right? For example, stake segment shows segment base address of stake segment, right? Similarly, data segment register shows base address for data segment. Similarly, ES register shows the base address for extra segment, right? But we need also offset part, and offset part is used in these four registers. Stake pointer and base pointer, they are basically used as offset portion. I mean, stake pointer and base pointer, both of these two registers are used as offset registers of stake, and how we will see in coming lectures. Similarly, SI and DI. SI means source index and destination index, right? So source index and destination index are offset registers of data segment, right? If I write this information for you, it will be like this. Let me highlight it for you. Okay, I'm gonna write it. Okay, I have mentioned these various segment-based addresses and offset registers for every segment. Stake segment, segment-based address will be SS register, and offset could be either SP or base pointer. And we will see them how we will use both of these register as offset part for stake in coming lectures. Furthermore, data segment. For data segment, the DS register will be serving as segment-based address content, and DI and SI means destination index and source index. Both of them or either of them can be used as offset, and we will see how we can actually use both of these two registers. And similarly, for extra segment, ES will be serving as segment based address, and DI and SI will be serving as offset part, right? And for code segment, I have already discussed it earlier, that CS will be used as segment based address part, and IP will be used as a instruction pointer, will be used as a offset part for code segment, right? So these registers are very important, and we can actually modify these content, and how we will see in coming lectures, right? Okay, this is one thing that we wanted to see. Okay, furthermore, we know that in every microcontroller or every microprocessor has a flag register concept, right? And you can eventually have it here as well. So this flags, right? If you see this button, flags will indicate flag uh, registers, right? So these are the flag which are available in 8086. CF is for carry flag, ZF is for zero flag, SF is for sign flag, OF is for overflow, PF is for parity, AF is for auxiliary flag, IF is for intra flag, DF is for direction flag, right? Direction of string function, which we're gonna see in detail in coming lectures, right? So these are various available flags, bits, which show different condition. For example, carry can be shown by uh, carry flag zero. Result can be indicated by zero flag, right? So these flag bits are available in flag, and you can actually easily access them just clicking on this flag button, right? We will see these flag registers in coming tutorials and their functions, right? But you can access and you can eventually verify these results with the help of flag, right? Okay, then there is a stake. Stake is wonderful and very important part of any microprocessor. You can access it, and how? This is your stake. It has various concepts with itself, so we're gonna see it in coming detail, because we have to cover them also in theory classes. So I will not discuss in this tutorial, but in coming tutorials of emulator 8086, I will be explaining how one can actually verify this stake and what these information indicates. But at this time, I can just show you that this is the 0100 dot triple FE is the address or the logical address, which will eventually lead towards certain physical address, and you can easily convert them using the same formula that I've already explained. But how these contents are placed in a stake, we're gonna see in coming tutorials, right? So this is a stake. Okay, then what else we need to explain, because this is a very basic tutorial in which I'm trying to teach my students how they can actually access and use this emulator, because this is a wonderful tutorial, a wonderful emulator which can actually let you know about every instruction usage in 8086. Okay, next thing that I want to discuss, you know that with 8086 there is a memory portion available, which is attached externally, and in this tutorial that is also simulated, or emulator shows also a fact of their simulation, right? And how you can click on this aux button, aux button, right? And if you click on it, there is further more options you can choose, and that there is a memory selection, right? If you click on it, so this is the memory which you can choose it, right? And furthermore, how this memory can be used, it's very easy. This is what the segment based portion of the physical address, and this is the logical address, right? For example, I'm right now uh, discussing 0100 4 times 0, so that is why it is adjusted here. And if you update it, it will update the any location. For example, if I want to go to 1234 hex, right? So 0100 colon 1234, it will generate certain physical address. If I will update it, look, 0100 colon 1234, right? So this value is shows for 1234. This value is shows for 1235 location, 1236 location, and so on, right? And these are what, how many locations? These are 16 locations, right? Sorry, 10 locations, and you can easily update them. 44 shows here, 45 shows here, and so on, right? We're gonna see in coming tutorials in detail how one can actually put the values inside this memory or in any specific location, and we can actually access them. And in coming tutorial, we will see also how one can actually move from that um, specific location to any specific register, right? So this tutorial series will help you guys to understand how 8086 instruction can be emulated and can be used to perform various functions within 8086 microprocessor. I hope this basic tutorials have already given you idea how one can use this simulator, right? So in coming tutorials, I will be discussing a single each instruction one by one, and we will be observing their effects on various registers. So thank you so much for listening. If you have any confusion or any query related to this specific environment, EMU8086, any query you can post in comment section, and I will try to answer them. Thank you so much for listening again.